Alright, time for another draftphysics.com, debatephysics.com also. But again, can't find the medium, the place to go debating. So I thought I would try to once again explain all of these problems in physics and do it in sort of attempting an explanation that can be used against something like Wikipedia. It sort of is peer reviewed. I heard Bill Gates talking about that, and yeah, it sort of makes sense. It is sort of a peer reviewed journal in some respects, and it just shows the limitations of peer review in the sense that the peers are all of the same baptism, the same religion, and so they're just gatekeepers, and they're keeping the opposing theories silent and quiet. But anyway, so part of what I'm going to attempt is that let's just say I am an alien, okay? Because I do find everything you people think and believe to be ridiculous and silly. So I might as well be from a distant galaxy, not only a different planet, but, someplace far, far away from, stupid. Anyway, and someplace where, yes, stupid is a bad thing. Something you try not to be. We believe nonsense, fabulists. Yeah, we frown upon fabling. And so I'm here and I'm going to try to explain all your mistakes and how you got it all wrong about how the material physical universe works. And yes, it is material. So that's the first thing to understand is there's two kinds of things, force, okay, and matter. All right. So that's the first thing to understand, and that the space contains the force and the matter. So the space is, as Newton would consider it, it's not a solid, okay? It's not jello, it's not a substance, but it might as well be, okay? It's the fact that it creates distance, that it creates space for things to occupy. It's just a fact. So yes, it's nothing, but it's a very, very profound nothing in the sense that you can't deny its structure. So a place in space is always the same space in space. It's always the same place in space. A place in space doesn't move, doesn't go anywhere. So in a sense, it is quiet. Okay, it isn't moving. And everything can be understood based on the quietness of a place in space. So anyway, so space is a real thing. It's not a flexible thing. It's a constant thing. It's the very dependable thing. Okay, so conventional physics makes a mess out of any kind of notion of space being indivisible and that they can create and destroy space. So the first law would be you can't create or displace or destroy space. Space is a place, is a place, is a place, no matter what happens. It's always a place in space. It never becomes a not place in space. All right, so it's three dimensions, three physical dimensions, and that's all there are. Up, down, left, right, forward, back, and obviously how you designate them just depend on your perspective. So it's just three dimensions of a substance that has no properties, space. All right. And the argument I'll make to you, it has been deduced through great thought and contemplation, all right, is that the matter, okay, basically comes in two forms. Something we might call a plus and a minus charged pieces, okay? So it's the electron and the proton. I guess this should be the plus because it's red, and this should be the minus because it's blue. So this would be the electron and the proton are the core of matter. And that if you combine these two things, you smash them together, you have what's called a neutron. Okay. And so the neutron isn't nothing. It isn't absent charge. It's the smallest dipole. So that is what to understand is exists elementally. These are the only elemental matter bits. All right, and the force, conveniently, comes in the same configuration. There are bits of force that are proton active, let's say, okay, proton force and electron force. And the force has the characteristic of being very discrete, small, and always moves at the same speed. It's always going the speed of light, unless it interacts with matter. And during the period of its interaction, it goes something less than the speed of light, because it's going to basically push the matter. So the mistake made is some understanding that electrons and protons can move without being pushed, without having something actively making them move. So the matter is dead. This goes back to Leibniz and Newton. You know, they had this kind of conversation about dead energy, not using the word energy, versus living force. So they had an idea of a dead force and a living force, which, you know, it's kind of not very good rhetoric. We should be able to improve on that a little bit, and just make the argument that the fact is the matter is by nature not moving. Electrons don't move elementally. Protons don't move elementally. And the argument is kind of a simple one. For an electron to move, to go somewhere, it has to be in a differential of this electron force. That is, more force has to hit it this way than hits it this way. And the consequence of that is that the force actually becomes part of the electron. That is, it sticks to it. So any differential in force it's exposed to, the differential will stick to it as elemental quanta of energy, little bits of this stuff called force. And the simple rules, I mean, it's two kinds of force, two kinds of matter, and essentially two kinds of interaction. It's 2 plus 2 plus 2 physics is how the real universe works. And so to lose this, once it's been in a field that's creating a differential, more blue going this way than this way, and now it's moving in this dimension with a velocity, and the velocity will be less than. So these little bits are moving the speed of light, but like Sisyphus, when they hit a boulder, now they can't be going as fast because they have to share their momentum with the bigger object, and so they slow down. Maybe one force bit means 10% of the speed of light. Might even be less than that. Could be more, could be a lot less. I didn't take the class at the alien planet where they know everything, so I don't have all those details, but it's something like that. Anyway, the idea would be is now the only way you can get rid of this extra force is it has to encounter more force coming this way. Now, obviously, that's going to be pretty easy, okay, when the entire universe is filled with this stuff. So the image of the universe you should have is that if a universe was this box, the box is full of little force bits, and they each have a vector, an arrow, pointing in a direction. So the universe is just full of these little bits. And the idea is, you know, from any location I put a piece of matter, it's going to seem like, okay, everything's out to get it, because obviously it's going to get hit by bits from every direction. And if it's an even number of, you know, if it's an evenly distributed amount of force, then it's just pressure on both sides. There's no differential. But when there's another piece of matter, that's when you create these differentials. And that's when you give the little electrons or protons momentum and make them move. And so the point is once they're moving, so once this has got this extra energy, if it encounters force from the other direction, then let's say there's one extra coming this way, well, then this one will reflect and this one will reflect. And, you know, a perfect kinematic type interaction. The energy will just keep going this way, and the energy will keep going this way, and it'll be perfectly efficient, no friction, no losses. And so this will just end up going a little bit slower. And then if it happens again, it goes a little slower. And it keeps going slower until it gets more energy from this side, then it starts moving this way. So it can only move in one direction in the 6 sub-directions. That is, you can only go up. You can't go down at the same time. You can only go forward. You can't go back at the same time. You can only go left and or right, but you can't go left and right. Simple kind of an explanation. Now, the key factor that creates charge, which is the special condition where you have objects that don't like each other but are attracted to the opposite, is made by the simple premise, the axiom, the fact, the law, okay, that if a proton force hits an electron, it's inert. It can't give it momentum, can't push. And it just goes straight through and it pops out an electron force. So it's converted into an electron force. So you could understand that protons and electrons essentially always radiate force of their color, their type. So a proton can only radiate red and an electron can only radiate blue. Now, it can absorb blue energy and store it as motion, but other than that, it always has to be in equilibrium. That is, besides its motional force that it's stuck to it, all the other force is essentially just radiating back to the universe. It's at equilibrium. And the only anti-equilibrium is when the electron actually moves. Otherwise, it just reflects everything. It gets hit from this side at the same time, blah, blah, blah. They just reflect. The energy always just reflects. Unless there's a disproportionate amount coming one way, then it'll store that little bit. So the two objects will essentially duplicate. Now, Maxwell was a clever fellow, and he got some stuff right. And this pretty much duplicates his drawings, exactly. Except the arrows are all pointing out. In this case, there are no in arrows and out arrows. But it's the same idea, the pressure of the two objects that they're creating. And obviously in this circumstance, you might be able to figure out even for yourself that, yes, if I put another electron here, they're going to constantly bombard each other with pushing force. And there's nowhere for it to go except to take any motion they have. So as they're moving towards each other, they're going to hit and reflect. The blue energy will hit and reflect, and then it's going to go back and it's going to reflect, and it's going to go back and it's going to reflect. So they can't move towards each other. And the consequence is if the energy doesn't reflect, if it sticks, it's going to be energy away from each other. So they're going to be very repulsive. You're going to see that in the sense that they're going to hate each other rather intensely. And the same for the protons. Protons are not going to like protons. But obviously if I was to put the two next to each other, then the blue force is inert to the red, so it just goes straight through. The red force is inert to the blue, so it goes straight through. And the blue force coming this way, there is no blue force hitting the electron coming this way because the electron converted it all. So obviously they have a huge amount of force pushing them together from the external pressure because there is no internal pressure. There's no pressure between them. A red never hits the proton from this side, and a blue never hits the electron from that side. So they're forced together. Now this is a rather perfect description of charge, and it's, again, 2 plus 2 plus 2 simple. Two kinds of force, two kinds of matter, two kinds of interaction, and you've finished. You've explained why there's charge. So huge indication that this is a correct answer. All right, because it really explains charge, a real fundamental aspect of the function of the universe. All right, so let's just make sure it's all clear. So the universe is full of this stuff called force. Now the force clearly, okay, it's little discrete bits, but clearly I can make patterns out of it. Okay, I mean I can push an electron, for example. I could push an electron. You can see that? Barely. Yeah, barely see that. I could push an electron. And I can hit it with force, and I can have it moving this way. Well, what's happening when it's moving this way is that it's going to react with any force coming this way sooner than it would, because it's changing its position in space. So now it's going to basically consolidate the energy that's in this space. This space has energy moving this way. If this electron is moving towards it, it's going to reflect that back into a much smaller space. So now the same number of arrows, let's say there was 7 in here, now the 7 arrows are going to be in this more consolidated space. And if this retracts, then you can understand that as it's retracting, it's going to reflect nothing, a lot less. And so that's what gives you this nothing in between the something. So you have a consolidated amount of energy, then a less reduced amount of energy, and then a consolidated and a reduction. So anything that oscillates or moves in an oscillatory way will in fact be creating a signal to the universe, okay, that's going to be in the form of a high density of force, a low density, a high density, a low density, a high density, a low density. And obviously that's the nature of a frequency, okay. Can't see that, but yes, a frequency is just that, and you can consider this wavelengths. You can talk about a wavelength, but there really isn't a wavelength. It's just a period. It's a distance, a time between events. And that's all you're really going to affect. So you can have events that happen rapidly, or you can have events that happen very slowly. And that explains the electromagnetic spectrum, which we'll get into more detail. But it's just to understand the force can be converted into these other things, these things we call magnetism and electricity and photons, light and gravity. All those things are made out of this elemental stuff, this little bits. They're the invisible things, and they all move, all the forces move, transfer information at the speed of light. So the speed of light, if you were doing physics right, you wouldn't call it the speed of light. You would call it the speed of force, because it's all the forces have the same speed. And all the forces are made out of the same quantum of energy, little discrete bits of energy. And all you can do is change the pattern the force has. You can consolidate it, or you can dilute it, reduce. And in doing so, you create a signal, okay, that will cause matter to behave in a certain way. So on our planet, we often use this tipping point argument to explain something. We'll explain how if I hit something and it's capable, it's not enough energy to knock it over, then the thing will swing back. And so there's a rule that if you want to try to knock something over, if you wait for it to fall back again, that is, if you hit it with a low frequency of objects, it'll just keep wobbling and it'll never fall down. But if you can hit it while it's still moving in this direction, that is a high enough frequency where you can add energy, velocity to its fall, then you'll tip it over. So the idea is you have to tip it you have to know what its resident frequency is, so you can know what your timing needs to be to defeat it in terms of knocking it over. So that explains the ultraviolet catastrophe and the idea of why certain frequencies have an effect and other frequencies don't, whether it's through transparency or some other phenomenon that takes place. The cause of that phenomenon is the fact that you're affecting the atoms with one frequency because you're able to keep them sustained in a wobble, like water in a microwave. And in another case, you're not, because the frequency is wrong, and so it doesn't allow the object to, what's happening is you're putting energy in this direction when it's moving in this direction. And although the energies can't cancel, in the force sense, you're not destroying them, you're releasing them from the object. So the force is being radiated out of the object if you hit counter forces. If two forces hit an electron from different directions, they don't cancel. I mean, they are going to reflect back into the universe, but they're not going to cause motion in the object. Where if they don't hit at the same time, they will create motion. All right, take a pause and erase and continue from there. All right, so there's so many ways it can go. I can try to explain gravity or magnetism, or which order you go through the manifestations of the simple idea of there just being force. Again, is that the only one I have? Yeah. Force. Or CE. Yeah, I don't do that right often. But anyway, and matter. Okay, and you have the different components. The force is always little stuff, and the matter is electrons and protons. And the idea is that this matter forms into things called atoms. And the simple argument would be is that the counter argument, where you've made another one of your monstrous mistakes, is to think of atoms as solar systems, as if there's orbiting objects, and complicating something that's very simple. It's a charge mechanism, as explained, and the neutrons, the creation of the objects that are smashed together, creates the opportunity, all right, to consolidate the matter in a form. So I could say if there was two protons and an electron. Now that would be a neutron and a proton. Okay, so that's the element of the basic element that exists inside of a nucleus, is this idea that we have a net positive. We have more protons than electrons. Again, this is a neutron. Okay, the neutron is not some different particle. It's a composite particle made of an electron and a proton, very close together. So the idea here would be is that no red force, okay, could ever get to this object. It just because the blue is going to convert any red into blue, and so it can't ever feel pressure. So the only pressure it can feel is the pressure of actually hitting the electron and pushing it, physically contacting it and pushing it, because it can't feel it as a force. And obviously this, so say if it was moving this way, okay, so it collected force here, and there'd be no way to reflect this force. You might be able to understand, how do I get rid of this force if no red can ever get to here? How can I ever get rid of it? The only way you can get rid of it is to move it this way or this way, and then it would now be exposed to the universe and could reflect and lose its energy. But it can't lose it as long as it's in this configuration. Any momentum will multiply, okay? And it can't be in any way reduced. There's no way to get rid of it, technically, except for, causing distortions, causing effects that are coming from the other side of, energy coming this way or energy coming this way can cause it to be exposed to the universe and lose its momentum. All right. But the point really is just that this is how you consolidate inside of a nucleus. So a nucleus is just the pressure, okay, of creating these geometric objects, and geometrically how they're exactly in what we know. It's only 100 configurations that you can create of these objects, that will work, that are maintainable. So you could argue that you could have another proton here, and you could have another proton here, and that they would combine to create a nucleus that's always going to be net positive. So it's going to have more protons than electrons. And so that's the nucleus. And then that makes it understandable why there's electrons on the outside, okay, that are attracted to most of this nucleus. Now you have to understand that this nucleus is going to have places where there's going to be an electron here and a proton over here, and that's going to say, electron on an electron is going to be repulsive. So it's only in certain places that it's net positive. So the electron has to be here. It can't be over here. It has to be here to be attracted. And the idea is just a simple geometry kind of argument that if I did place, 4 things, let's say, and if I took magnets and I put them all north facing between glass so they can't flip, you could sort of understand I could put a positive here, okay, a south facer, and that these north facers would be stuck in these positions. They couldn't move into the positive, because to move into the positive they have to get closer to these other electrons. So to move here, okay, means they're getting more repulsive pressure from this and this electron, and that's going to push them away. So there's a balance that holds atoms together between the pressure, the attraction to the proton, and the repulsion of the electrons. And so all of this is under pressure, okay, that's all moving towards the nucleus. So the electrons are moving, they want to go in, but they can't. So there's a certain pressure pushing them in, but they can't overcome the amount of pressure they're imposing on each other. So they have to move the other electrons to be able to move this electron. So they don't have enough energy to push themselves into the nucleus, or closer to the nucleus. So you can understand, the more electrons you have, the more complicated this field of electrons becomes, and they're all going to share pressure. So the pressure between all the electrons is all going to be the same, because they're all finding the niche that equalizes their pressure. And so when 2 atoms share an electron, they physically share it. Okay, the mistake is to think the electrons have motion in some other direction than in. Everything in the universe is being pushed into a center. That's the consequence of having a force on the outside, and the matter bits being moved by the force, is that everything will tend to go that way. So if I created a box with a bunch of indestructible constant velocity BBs, and you put objects inside that box, and the BBs never lost energy, they would push the 2 objects into each other, just because of the fact that they're going to block, they're going to shadow each other, the 2 objects, and essentially create less energy between them, and they're going to be forced together. So it's a push universe. I mean, it's probably a key concept, is that it's push. There is no pull as an elemental function. It's really easy to push something. You throw it and hit it. It's really hard to imagine how I pull something. Pulling would have to be magic. I can't pull something by merely banging into it. There's no way to pull something by doing something as simple as just moving in a straight line and crashing into it. Straight lines are another real fact of the universe. Everything is a straight line. And the real universe has a lot of Elysium in it. Has a lot of straight lines being changed, but they're all straight lines. The universe doesn't have any round in it in terms of a motion. That's only emergent. The real, any surface that looks round is really a bunch of little vectors, little straight lines. Anyway, that's a whole nother subject, frankly. So back to this point. So I have another atom here, and the fact is the atoms actually physically share electrons. That is, the electrons aren't swirling all over the place. They're in pressure, constant tension, and they're in positions, and you basically physically share the electron. The electron is in a position, and both atoms are tug-of-warring over that electron. And so it's in even more tension, because now it's an atom combined with another atom, and it can do that with 2 electrons or 3 electrons. It can make all kinds of different bonds. But they're literally shared. This electron does not disappear over here and fly over there and fly over there. It doesn't do any of that. It jiggles in this space, and that's the important part. It just moves a little bit this way, a little that way. Everything's jiggling, okay, because it's a very high pressure system with a lot of energy in it, and there's always at any one moment there can be one more piece of energy coming this way, then went this way, so it moves a little bit that way, and then the next moment there's a little more going this way. So it's constantly, everything's constantly in this field of randomized pressure. I mean, it's not random, but it's randomized. And clearly, when there's another object in the vicinity, it's not going to be random at all, because the other object is going to be reflecting the universe and creating an effect this object will see. It will see the other thing in its environment. Just as we don't feel it, but I mean, right now I'm getting hit by the photons off the computer screen. I'm getting hit by the photons coming through the window. There's different things that are creating an imbalance in the energy field I'm exposed to. But it's such a tiny imbalance, it's not going to move me, because I'm billions and trillions of electrons. But the fact is, it is moving electrons on me, on my surface. It's just not enough to move the giant object that I am relative to an electron. So that's another key thing. Like push, another key thing to understand is there's only one universe, and it's this universe. It's electrons and protons. The smaller verse is the only verse. Okay, the rest is all emergent. Everything that happens has to happen to these electrons and protons first before it happens to anything else. This is the real universe, and it's running very fast, the speed of light fast. I mean, there's trillions of interactions in 1 second. 1 second, there's all kinds of interactions that are taking place in that small universe. So the time scale is so different. You know, we're, you know, we function so slowly compared to that speed of light that the rest of the universe is functioning at. So the machine is doing so much more. It's almost like a computer. It's doing so much more in 1 second than we can consciously understand, or even come close to even having a glimmer of an understanding. Because even our sentences are incredibly slow. I mean, you know, it takes like 1/10 of a second for each word, and it's just so slow compared to the speed of light. So anyway, their model of the atom is just all wrong. Yes, it is electrons and protons. The neutron is, it's not a real thing. It's a composite, so it's not elemental. So it can almost be ignored, all right, because it really isn't a player. You're still, the only thing that matters is these pluses and these minuses. Okay, whether they're stuck to each other, not stuck to each other, doesn't change much, because their behavior is still going to be basically the same. They're functioning as bits of matter, electrons and protons. It's not functioning as a neutron and a proton. Okay, and atoms are just there's no momentum again in the matter, except momentum in the in direction, the pressure. So that's why these nucleuses are made inside of suns, is because you can only smash this stuff close together like this under high pressure. You have to have a lot of energy moving in towards to smush the protons and electrons close to each other, so you get rid of all the extra force that might be between them, and you only have the force pushing them all towards each other. And so that's how you release energy, is you're really just releasing all of the pressure going in and allowing it to escape. So the nucleus is made under very high pressure, and when you break it, okay, in a low pressure circumstance, you're essentially creating, you're releasing a vacuum in a sense and creating a huge implosion, which has the same effect as an explosion. I mean, moving matter in is the same as moving matter out in terms of its displacement of the field. It doesn't matter to the field whether I'm doing this or whether I'm doing this. The field just sees it as a change in how much pressure there is, and that's it. But it's not a coincidence, or just not some just silly fact, that you need high pressure to make a nucleus. And so you're really just pushing everything together. You're not spinning stuff. You're pushing it into each other. So the idea would be is if you do this efficiently, you're basically saying that, yes, I'm going to make matter really compact. In an ideal sense, it would be a perfect checkerboard of electrons and protons. And you could understand that that's basically a neutron star. So once I compress it really tight, oh, you can't really see that. Unfortunately. Yeah, well, I'm only human. Oh, wait a minute, I'm not human. Yeah, aliens are a little dyslexic, so they have some issues. I didn't say I was coming here as a perfect person to inform you. Obviously they didn't, they send people who they don't like very much. So that's why I'm here. Is apparently they didn't like me very much. So they sent me here to go educate the stupid earthlings. So anyway, the neutron star would be like this, very compact. You're getting all the electrons and protons are essentially now in a configuration of, this is a neutron, 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 this is a neutron. They're all in very tight configuration. So you have a whole bunch of a high density of matter. And this is also why it can become very magnetic, is because obviously these are all a bunch of dipoles. And if you arrange it, appropriately, you'll end up with something creating a very strong magnetic signal, because all the dipoles will be, in certain locations, it will be very strong in terms of the pattern created to the external world. All right, but that is another subject, magnetism. All right, so the basic point is that this grammar school description of an atom with these swirly bits, around a nucleus, these orbits is not right. Now, the fact that they are at different heights is just a fact of, imagine if this was a proton and these were electrons. This is a positive nucleus and these are electrons. You can understand that if I was to add another electron, blue, obviously. If I was to add another electron, it can't be added in here because there's too much, that would create too much pressure. So it sits out here. So that's the next energy level. And then I fill that energy level, and then there's a next energy level. So the fact that there's energy levels is just created by the fact that there's field lines around a magnet. Because what you're doing is creating, when you create a magnetic field line, you're creating basically a positive, negative magnet. They're all pointing in the same direction. So this is like a north magnet and a south side and a north side and a south side, and they repel each other. That's why there's a space between the field lines. It's because the magnets you're creating are repulsive. They're aligned the same way, so they're repulsive. So the induced magnetic field, which is opposite the original magnet, right? The original magnet is north, south, and you're creating an opposite field, of magnets, and they repel each other. Well, the same thing's happening inside the atom. The atom is saying, look, an electron repels an electron. So if I have a field of electrons, they're going to repel each other. So obviously they're going to create energy levels, because there won't be any room to fit more in the inside. That would take more energy. So that's the other thing. They think the outside, you people think the outside orbit is the high energy one. No, it's the one in here that's the high energy one. The one on the inside is the high energy. Like, those are the electrons under the highest pressure. The ones on the outside are under almost no pressure. All right, so, you got that backwards with like so many other things. All right, so maybe we'll just say that's the important part is the push part, recognizing that the real focus of the universe isn't to move something in orbits, it's to push everything into each other. All right, and so the electrons don't have some sort of multiple kinds of energy. Their energy is basically dictated by the simple charge field. So whatever the charge is will decide which way they're going to move. They're not going to acquire multiple, complex orbits and all of that kind of stuff. It's not necessary to think of it that way. It's just think of it, the external pressure is always pushing in. Everything's always going to end up pushing in. So like I said, even if I had a neutron, I guess I should have to erase this. So I have a neutron, and it's looking at an electron, or it looks at a proton. Some field, some part of the thing is either pointing, it's either saying negative or positive. So if I had an electron here, I really have to get a different pen. Unfortunately, that one's done. All right, so I have an electron here, and I have the proton here. All right, let's say I'm going to move, I'm just going to see what happens to a neutron. So if I had a neutron here, okay, which is the proton and the electron, you can understand that it's repulsive here and it's attractive here, so it's going to do just like magnets. It's going to flip. And as soon as it flips to green, red, it's going to move right in, right? But it's going to do exactly the same thing with the electron. You're not going to be able to tell the difference in its behavior. So it's going to end up going in to the proton. Well, what's it going to do when it's here? It's going to do exactly the same thing. It's going to rotate. It's going to become, it's attractive. Whoops. I should reel it the other way. Well, it doesn't matter. You get it. So we start off this way. It flips to this way, and it's going to do the same thing. It's going to plow right into the electron. So yeah, it looks neutral because it's going to do the same thing. Whether I put a negative charge, well, that's the positive actually, or a negative charge, it's going to do exactly the same thing. It's going to move right into it. So that's going to look like neutral, but it's not really neutral. It's just a flipping magnet, and it's always going to go towards the South Pole or the North Pole. I put a magnet above a pole, it's going to go flying right into the pole. So that's what the neutron's kind of demonstrating to you, that the neutron is a dipole. It's the first original dipole. And it behaves just like a dipole, which is, it's going to move like a magnet. And it's going to move into either the north or the south side. All right. And so it's going to look neutral, because it's not going to show itself to be positive or negative, because it's not going to repel from one of these. So it's going to look like a neutral, but it's not really neutral. All right. So we'll call that a first video, and then we'll go see how many parts I need to do, and to make this argument somehow constructed into a paper proposing that all of, I don't know what, 80% of the axioms of physics are misguided or poorly founded, and therefore incomplete or grossly incorrect. I mean, it's created a bunch of incomplete theory, partially right, or a bunch of stuff that's just grotesquely right, like, mv squared, the living force, kinetic energy. Just absolute nonsense. All right, so till the next time and such.